Hello everyone, this is a follow-up to a short I made not too long ago where I connected my ham radio to my desktop using a USB to serial adapter to toggle the PTT button. I'm now going to take that and put it into a project box that will allow me to have a more permanent TNC. Though this TNC only controls the PTT button, it's not a more elaborate one that can control like channels and frequencies. It's still very useful for doing APRS, and I've had a lot of fun doing it, even talking to the space station with it. So come along and maybe you can use this to fuel some of your projects and create a TNC for your simple radios.
So shortly after I discovered that my antenna and radio could be used to listen to the International Space Station and receive the slow scan TV, I started looking at the International Space Station's ARPS repeater and wanted to play around more with APRS. I decided to look in how I could use my radio here to send messages through that ARPS repeater. In that journey, I came across this program called UISS, and this just helps you format the characters that are supposed to be in the APRS packet, um, so you can then convert them to the right audio frequencies and send them up to the International Space Station. When I first came upon this program, I thought that it did everything. Later to find out that all this takes care of is the messages, the to and through what gateways do you want to do this, send your message, and then it has three different types of messages you could set up. One specifically for an APRS message, one that's just text data, you can send whatever you want, and then this one that's TXR APRS position with a small comment at the end. This program actually sends the data over to a different program. This is called sound modem, and what this one actually does is convert the message from the audio into from the text into the audio that's sent out. That audio then sounds like a 1990s dial-up modem that sends the messages back and forth, and I can actually show what it sounds like waiting for a packet to come in. Um, but I found that this program right here could actually control a USB serial adapter and send messages over it. Oh, there you go. That's what it sounds like when the data packets come in. And uh, I then started investigating how does that actually work, and I started reading into the manual that's on sound modem. And right there, it clearly says if you're using a serial port, the RTS is used for channel 1 and DTR is used for channel 2, and explains how you could set it up to use these to actually key a PTT button. Now, my radio is not a typical radio that is easy to hook a TNC up to, but I was like, okay, knowing what I know about electronics, I know how these USB serial adapters work, I know which one's the DTR pin, how can I now make this toggle my PTT button? And I realized what I needed to understand was the interface the microphone plugged into. I got digging into the user manual for my radio, and sure enough, I came across right here. And I was like, well, that just lays it right on out. The four pins that interested me most were these: the PTT, the ground for the microphone input itself, and another ground pin. I don't know if these are the same. They might be, but I'm going to treat them as if they're differently. Um, but from this, I then started doing the experiments with a BJT and seeing what I could turn on. Before I did all those experiments, though, I actually took an RJ45 connector that I had that's the push down Usually you'd see these in walls, and created the adapter so I could make some measurements on it. So you see I have that RJ45 connector that's connected to the blue wire all the way up to my radio. And right now I'm measuring the PTT button with respect to the ground on the radio, and then I see that it is 4.21 volts. So that tells me that this should be an active low PTT. Now what I want to measure, just to have a reference point, is the microphone right here. I should have taped this out. I might go ahead and do that so I don't accidentally touch things. There we go. Just put that tape there to hold those wires in place so they won't accidentally bump each other. So now I want to measure the microphone input, and you notice that's almost 8 volts. So what that tells me is I'm going to need to have a decoupling capacitor to make sure no current is backfed into my computer on the headphone output so it doesn't damage it. So after I took those measurements on my radio, I sat down and drew a small schematic. It was first on paper, but I wanted to put it over to here so I could have a better idea. I decided from measuring what I measured between the PTT and the ground that inside the radio had to be something like this. You'd have a pull-up resistor. I don't know the value. I know that there's ways that I could discover it, but it really wasn't important to me, the value of it. That would tie to a pin somewhere in the radio that would make it do all the controlling for mixing the microphone and allowing that to go out the final amplifier modulated on the carrier wave. I then took what I had learned from the user manual and drew out what the connector should look like. Now, as I talked about when I measured the microphone plus signal, I noticed that it had that DC offset. And so I knew for sure I was going to need some type of isolation capacitor. I looked it up, and there's lots of debates on how big, what size should you use, and I decided that a 10 microfarad would be the best, and I knew I wasn't going to create a filter that I would lose too much of the audio that I needed to with that size, but I would do the DC decoupling and not allow voltage to go into my PC and damage it. Doing some measurements with the USB adapter that I have up here, and just a block of it, I realized that when it wasn't transmitting, the RTS pin was set high, and when it was going low. So that signaled to me that I was going to need a PNP type transistor, and one that would be turned on when it was an active low transistor, and that would tie the PTT button to ground. So I just chose a 3906 and put it in with some type of resistor to make sure not too much current didn't go into the base, and set that up on a breadboard. The first thing I noticed when I plugged it in, it was all set up, hooked up to my radio, even this piece here. As soon as I plugged it in, the USB in, my radio started transmitting really quickly. And I quickly unplugged the USB adapter and was like, what's going on? I checked the circuit and everything was fine, so I plugged it back in. The same thing happened. And then it clicked to me. When this USB adapter, when the serial adapter was enumerating on the USB, it was driving those pins all kinds of levels, and thus it was toggling this RTS pin on and off, on and off, on and off, which was causing some transmissions over the radio. So in order to avoid that, I then decided to put a switch in between where the pin came off of the RJ45 connector and right into the transistor. And this would allow me to be able to break it and only have it enabled when I knew I was ready to transmit. And to help me visualize this a little bit more, I dug through my supplies that I had and found that I had a 6-pin switch. So I set it up with an RG LED such that when I'm not ready to transmit, the red's turned on, and when I'm ready to transmit, the green turns on. And now I plugged all that in, and I've been transmitting packets. I'll take you over and show you that on the breadboard right now.
So now I got everything in the breadboard with the switch and the LED right there, and if I flip the switch, it switches to green, meaning I'm ready to go, and switch it back. It's hard to do one-handed, and it stops. I've tested this a number of times and it works perfect. You can see my packets being sent out when the switch is on, and when it's in the off position, nothing happens. Just the way that I want it to be. So from here, I'm now going to take that and move it over to this breadboard. I'm actually going to keep this circuit intact as it is so I can use it as a reference as I start to put down the pieces on this protoboard actually. And then I'm going to take that and move it into a little project box that I got, and this will become a permanent setup. So some of the things that I like to do when I'm trying to lay out a project box is I actually wrap it in tape. This allows me to be able to draw on it and get an idea of how I want things laid out without making it too permanent. So this right here I laid out specifically to house that connector. I decided rather than buying a panel one that would theoretically mount better, I got a whole bunch of these just lying around. I'm just going to cut a nice little square out and put it into place right there. I also marked dead center here. I've been thinking about putting in one of these connectors. This is a 3.5 millimeter jack right here that I could plug in for the microphone. After I'd marked that, I realized I need to go back and look at this a little bit. I'm going to need a space for this where the USB cord could go in. So I'm actually going to change this side up a little bit and mount the USB on this side. So it'll be USB on this side, Cat 5 will come out on that side. Most likely I will put the audio on this side or that one. Haven't decided yet, but it'll end up being one of those sides. So for the layout on the top piece, one will be the switch, the other will be the LED. I did the same thing, put some tape down, and then kind of crossed it, put an X through, found the center, and then went equal distance from both sides. But I kind of messed up when I drilled it. I didn't get the drill on just right. It kind of slipped out of my way. Wish I would have had something holding it tighter, but it'll work good enough for this project. And now I'll work on putting the circuit onto the protoboard. So I got the entire circuit onto the protoboard, but one thing I decided to do just to make it easier is to make it more modular. So this connector right here will connect to this one on my RJ45 connector. That will just allow me to be able to install everything and then hook it up as I need. This is the 3.5 millimeter jack connector that I have that will be my audio input to the box. And then this is the switch. I did the same thing for the switch right here. I soldered some jumper wires that I had that were broken onto here, and did the same thing with this one. And all of that was for was just to make it more modular. I have posts throughout here of where to hook up the different pieces, and I believe that will help me fit it better into the box. So I'm doing some fit testing right now. I missed making some videos of the other fits that I was trying to do. That's in crooked. I didn't cut it straight enough when I was cutting it with my Dremel, which is kind of hard to do. This plastic was a lot harder than I thought it was. It's not ABS. I don't know what it is. I picked the box up for free, but it's definitely a lot harder than ABS. The other issue that I had was with this, I drilled the hole too low and slowly had to bring it up in order to get the USB to fit in. One of the other issues that I'm running into is I made these cords kind of long. I should have trimmed them down, especially the leads on the LED, because they're just not quite fitting in. I put the heat shrink over it to kind of insulate the end pieces, but it's making it kind of hard to fit everything in, but it will be able to get to fit in. I'm really liking how it's turning out with all those other objections. This hole actually works great right here for that. I just got to put it into place and screw it on. But it's coming right along. I'm going to do a couple of tests to make sure that it works at this stage. And then I'm going to go ahead and finish it up. I also found out that the hole that I drilled was in this right here was a little big for the LED. So I'm probably figure out something, maybe a little bit of glue. I don't know. Small mistakes you make. But yeah, I'll get it all wrapped up. So here it is. I got it all in the box. You could tell that it's off right now, and that was because I just barely plugged it in. I didn't want it to go up and start doing the automatic broadcast thing. Flip it over to green. My radio's not broadcasting anything. It goes on up, and I'm on my APRS frequency. I have it programmed in my radio to say APRS, but it's actually 144.390 megahertz. And so now I'm actually ready to go and test on. One quick thing I did to help hold that LED in place is I put some tape on the back like that. I don't think it's going to be the best, but it's better than nothing. And I'll probably drop some glue down on the front once it's all back together.
Here we go. We're going to run with the test. We're back in the UISS, and how we can tell if the test is working correctly is we'll see some of these red things. This is from a different radio that I have running, that's running APRS. It's my Anytone. So I should see when I click on the position up here, something similar like that to coming back. That tells me that my signal was able to make it into the digi-repeater. So one of the smart things when I'm doing these tests is I try to wait for it to be quiet here, because that tells me that, hey, any of the repeaters are actually ready to listen to a signal. So once it quiets down again, I'll go ahead and hit that button. And there we go. I got one back in on it, and it was digi-repeated at least once. So it works, and I'm not sure if you can hear the fan in the background. That was my radio kicking on, sending out the packet. And all that packet did is said, hey, this is where home base station is, and we'll go try it again, see what happens. We can get another line or two in. There we go. This is awesome. Makes me really happy.
Another thing that I made that I want to show off real quick is this box. All those These were leftover parts that I had ordered in to make that TNC. Those are just the 3.5 millimeter barrel jacks, and then this is just another one of those switches right there that are the 6-pin. And all this does, this allows me to select whether it's going to my PC, whether this radio is going to go to my PC on this one, or a speaker that I have right up there. All I have to do is flip that switch, and the sound will either come out of the speaker or go into the computer. Makes it really convenient when I want to hurry and put on my microphone again and talk on the radio as a normal radio, and makes it so I don't have to unplug a whole bunch of cords, just the microphone. So here's the finished project right here. It turned out really well, in my opinion. I like how small it is. I'm going to end up probably moving it, mounting it so it's all nice and hidden behind my computer. But yeah, it works great. It does exactly what I want it to do. I may do a follow-on video just exploring some of the stuff that I learn and do in APRS. I have a couple of other handhelds that I would like to make something similar for, but more small and compact, that I can have in my truck and connect to my cell phone. But anyway, there it is. I'm very happy with the way that it turned out. Thank you for watching.